A team of international astronomers have detected an exploding star that's thought to be the oldest and most distant object ever detected.
Since its launch into space, the James Webb Telescope has captured mind-blowing pictures and taken us on a voyage through time. From images of Saturn's rings to detecting 500 unknown objects flying through Earth's orbit to pictures of Proxima B and colorful nebulae. The telescope's voyage through the cosmos has marked a major milestone in space exploration. However, what it just captured changes everything. The foundation of science as we know it is shaken. The telescope captured a 13.8 billion-year-old object. This celestial object is practically older than when the universe. It predates the Big Bang. Does this mean that the Big Bang theory is wrong? Join us as we delve into the 13.8 billion years of objects that the James Webb Space Telescope detected. 13.8 billion-year-old structure just detected. Deep in space, about 200 light-years from us, there's an old star named HD 140283. It's near the Libra constellation. This star moves quickly through space, giving us interesting peeks into the chaotic history. Picture a time 12 billion years ago when our Milky Way was just a baby, taking in a small galaxy that used to live with it. What grabs our attention about HD 140283 isn't just how fast it travels, but how incredibly old it is. Out of all the things we've looked at in space, Methuselah's star is one of the oldest. It's named after a character from a story who supposedly lived for a long time. At first, people thought Methuselah's star was a super impressive 16 billion years old, but now they think it's a bit younger, around 14.46 billion years. Astronomers are a bit confused because the age of the whole universe is about 13.8 billion years, and Methuselah's star seems to be older than that. The confusing situation made people ask important questions about how old the star is, how old the whole universe is, and if our methods for figuring this out are correct. Let's make it simple. Figuring out the age of things in space is like solving a tricky puzzle. Like our sun, stars shine for a long time, making it hard to know how old they are. Astronomers act like space detectives, looking at changes in brightness and color as clues. They compare these clues with models that predict how stars change. One clue about age is how fast a star spins like a slowdown wheel. Stars do the same thing. Astronomers have a clever way of knowing the age of stars. They compare how fast stars spin at different ages, and this trick is called gyrochronology. Stars also share their age secrets through something like magnetic gossip. Bursts of energy on a star's surface are like a star showing youthful excitement. As stars get older, this energetic show slows down. Astronomers, who are like space detectives, use fancy methods like astroseismology. It's like listening to a star's inner conversations by hearing vibrations caused by waves inside it. These vibrations tell astronomers how old the star is. For example, using this method, they estimate the sun's age to be around 4.58 billion years. Let's talk about Methuselah's star again. The idea that it's super old isn't just a guess. Astronomers looked at its cosmic surroundings to figure it out. Stars are grouped by how much heavy stuff they have, like iron. Our sun is in the blingy group called Population 1, but Methuselah's star is like an old-school rock star in Group 2, with fewer heavy elements. Astronomers use this stellar bling to play space detectives and uncover the age stories of these stars. Now picture a bunch of stars, the hypothetical Population 3, which scientists think could be similar to the universe's uncommon jewels. While they're still behind the scenes and haven't shown up in our telescope spotlight, astronomers suspect these stars might be the rock stars of simplicity, containing hardly any heavy elements. To comprehend this stellar lineup, let's return to the universe's early days after the Big Bang. Envision a cosmic kitchen filled mainly with hydrogen and helium, like the universe's fundamental components, approximately 92% hydrogen and 8% helium, or, if we estimate them roughly, 75% hydrogen and 25% helium. In this cosmic concert, the initial performers were the population of 3 stars. They were sizable and hot, consuming their cosmic fuel rapidly, converting hydrogen and helium into denser elements. When these early cosmic titans exploded, they dispersed these denser elements into the immense cosmic expanse. Following was the population of two stars, appearing a bit later, but still in the universe's early stages. Their original materials were light on denser elements, particularly iron. Many twirled through their stellar life cycles, erupting into supernovas and contributing denser elements to the universal blend. Ultimately, the population of one star, including our Sun, emerged as cosmic tardycomers. They developed from enriched gas clouds, mingling with remnants from the prior population of two stars. Some of these population two stars also ended with a burst, adding more dense elements to the cosmic formula. Now, the significant query is, does this stellar narrative throw a cosmic curveball at the Big Bang Theory? It's a puzzle, but here's the turn. Given the uncertainties, there's a 70% likelihood that Methuselah's star, the ancient celestial rover, could be somewhere between 13.66 and 15.36 billion years old. The lower limit even matches the age of the entire universe. And there's a 30% likelihood that this ancient celestial wanderer's age is playing beyond the cosmic rulebook. Similarly, there's a 15% likelihood it's not just slightly beyond the norm, but even younger. Picture it rolling a regular six-sided dice and wishing for that elusive six. Statistically plausible, right? But no matter these cosmic surprises, what's sure is that Methuselah's star is not just an old space expert. It's the granddaddy of stars. We've managed to give it a pretty accurate age tag. Now here's where it gets mind-boggling. Let's change the cosmic story. Instead of puzzling about whether Methuselah's star could be a couple of billion years older than its galactic neighbors. What if the universe itself is younger than we once thought? Grasping 13.8 billion years is like trying to understand the vastness of space itself. Imagine the whole story of the universe is like a big calendar, starting with the Big Bang as the grand New Year's fireworks. Earth wouldn't even join the celestial party until the very end of December 31st. Human record history? Well, that's just a tiny moment in time, lasting only the last 10 seconds. Our space investigators determine how old the universe is by looking at old starlight born a few 100 million years after the Big Bang. As the universe expands, it changes the light in a cosmic way called redshift. In our strong effort to figure out the universe's secrets, humanity is on a mission beyond time itself. We're trying to find answers to really old questions that are part of the very essence of existence. And here are some of the other things that the James Webb Space Telescope has been able to capture in its voyage. Pillars of creation. As per NASA, the picture is in the expansive Eagle Nebula, positioned at a distance of 6,500 light-years from our planet. The biggest and most potent space telescope on Earth has taken pictures of the famous pillars of creation, massive formations of gas and dust filled with stars, as reported by NASA. NASA's Hubble Space Telescope initially took pictures of the pillars in 1995. However, owing to Webb's infrared skills, the more recent telescope, sent into space less than a year ago, can look through the cloudiness of the pillars, uncovering newly forming stars. The Webb images display vivid red, molten-like spots at the tips of various pillars. These are ejections from stars that are still forming, just a few 100,000 years old, NASA said. These young stars periodically shoot out supersonic jets that collide with clouds of material, like these thick pillars, it added. We had to do the pillars of creation by popular demand, Klaus. The picture, spanning approximately 8 light-years, was snapped by Webb's main imager, NIRCam, specializing in near-infrared wavelengths that our eyes can't see. The colors in the image were converted into visible light. NASA states that this fresh image will assist scientists in refining their theories of star formation by pinpointing much more accurate numbers of recently developed stars, along with the amounts of gas and dust in the area. The findings of the telescope cleared our doubts concerning the pillars of creation and answered all the questions that were on the ground before regarding it. Jupiter features. NASA's James Webb Space Telescope recently made a big discovery in Jupiter's atmosphere, revealing something we didn't know before. It found a fast-flowing stream of air over 3,000 miles and 4,800 kilometers wide and sits above the main cloud layers near Jupiter's equator. This discovery tells us more about how Jupiter's well-known windy atmosphere works. It also shows how good the Webb telescope is at watching and studying things like this in the atmosphere. The research team reviewed information from NASA's Webb Telescope's Near-Infrared Camera, NIRCam, recorded in July 2022. This data study was part of the Early Release Science program led by Imke de Pater from the University of California, Berkeley, and Thierry Fouché from the Observatory of Paris. The program's goal was to take pictures of Jupiter every 10 hours, like one full day on Jupiter. They used 4 filters to capture these images, each capable of spotting changes in small atmospheric details at different heights in Jupiter's atmosphere. Even though Jupiter and Earth are quite different, Jupiter being a gas giant and Earth a solid, moderate climate planet, both planets have layered atmospheres. Earlier missions concentrated on examining the lower and deeper parts of these atmospheres using different types of light, like infrared, visible, radio, and ultraviolet. This helps observe things like big storms and clouds made of ammonia ice. However, the James Webb Space Telescope stands out by going deeper into the near-infrared spectrum. This allows it to explore the higher layers of Jupiter's atmosphere, which are about 15 to 30 miles, 25 to 50 kilometers above the planet's cloud cover. In these near-infrared pictures, the hazes in the upper levels, usually appearing blurry, now show more details, especially around the equatorial region, thanks to the capabilities of the Webb telescope. The recently discovered fast jet stream on Jupiter zooms at around 320 miles per hour, or 515 kilometers per hour, twice the continuous wind speed of a Category 5 hurricane on Earth. This high-speed jet stream is about 25 miles, 40 kilometers, above Jupiter's cloud layers in the lower stratosphere. To study how wind speed changes with height and identify wind shears, the research team compared the wind patterns observed by the James Webb Space Telescope at higher altitudes with those spotted by the Hubble Space Telescope at deeper layers of Jupiter's atmosphere. We knew that Webb and Hubble's different wavelengths would show the three-dimensional structure of storm clouds, but we were also able to use the timing of the data to see how rapidly storms develop, said team member Michael Wong from the University of California, Berkeley, who led the related Hubble observations. The research team wants to conduct further observations of Jupiter using the James Webb Space Telescope to investigate whether the speed and altitude of the jet stream undergo any changes over time. Due to the finding of the telescope, our knowledge of Jupiter is enhanced and our uncertainties are revoked. Proxima B. The James Webb Telescope has recently made some amazing astronomical discoveries, offering us a new view of the universe. One of the most exciting findings is revealing the sharpest image of Proxima B, a possibly livable exoplanet just 4.2 light-years away from us. Proxima B gets a similar amount of energy from its star as Earth gets from the Sun, sparking speculation about the existence of water and the chance of life on its surface. However, whether Proxima B is habitable is still a topic of discussion because it faces intense ultraviolet radiation from its star, making it unwelcoming for life as we know it. Nonetheless, the powerful telescope managed to capture one of the clearest images of the planet. Initially, it seemed like assumptions, but then after seeing the image obtained from the telescope, we have hope that there is an exoplanet that can be habitable. Tarantella Nebula. Since the beginning of time, attempts have been made to provide clear images of the Tarantella Nebula because scientists grew anxious to see what it looks like. Finally, it was taken by the JWST in September 2022. This photograph showcases the Tarantella Nebula, a celestial breeding ground situated approximately 161,000 light-years away from our planet. The picture of the nebula displays a region spanning 340 light-years. The expansive gaseous expanse reveals the origin of numerous star systems, with galaxies illuminating the backdrop. Afterward, the anxiety of the scientists dropped because they now had a clear picture of the tarantula that they could look at and study. Neptunes Rings. Due to Webb's substantial technological advancement in contrast to the interplanetary Voyager probe, researchers successfully captured images of faint, dusty rings encircling the planet for the initial time. Instead of the planet's typical blue atmosphere, the telescope's near-infrared wavelength illuminates Neptune's elevated altitude clouds. Neptune's rings have not been seen clearly before, so assumptions were made to fill in the gap of the assumptions. But now there are images to show what the rings really look like. The JWT Deep Field. This marked the inaugural authentic image from JWST, the primary publicly disclosed picture employed to showcase the telescope's tangible capabilities. The sparkling points in the image are not stars, but entire galaxies. Every minuscule light point in the photo within the cosmic void represents a complete galaxy with hundreds of thousands of stars, captured through a mere pinhole section of the night sky. The curvature that distorts the light in certainly featured galaxies is precisely what JWST was constructed to examine. This bending phenomenon, recognized as gravitational lensing, arises when the mass of colossal entities distorts the light from objects situated behind them. This effect enables JWST to scrutinize the very origins of the universe more closely. The telescope also shows its ability to achieve beyond what we imagined, and tries to expose us to the possibilities of many other things. Karina Nebula. This was one of the first pictures shared by JWST, and perhaps its most famous. The Karina Nebula is 7,600 light-years away from Earth and stretches over 300 light-years. This amazingly colorful picture displays where thousands of stars are born and eventually meet their end. The dusty storms in these cosmic cliffs create complete solar systems over thousands of years. Similar to other nebulae observed by Webb, the telescope's ability to see in infrared unveiled hundreds of stars that were previously hidden behind clouds, including some protostars shooting out jets. The James Webb Telescope gave a closer and better view of the Karina, thereby countering some assumptions that were already on the ground before the telescope was set to be used. But there is a discovery the James Webb Telescope has made that nobody is talking about yet, and it's the biggest one so far. It has sparked immense interest among scientists and space enthusiasts alike. The James Webb Telescope has just revealed our brand new JWST Special Edition phone cases, which are on sale for the new year right at this moment. Discover them yourself by clicking on your screen right now, or check the first link in the description. Let's hear your thoughts in the comments about this venture. Also, don't forget to like this video and subscribe to the channel for more. See you soon.